Ionic compounds such as sodium chloride are held together by ionic bonds. All ionic compounds contain a metal combined to a nonmetal. So when a nonmetal, such as chlorine, combines with a metal like sodium, the chlorine atom would have a stronger attraction force for electrons than the sodium atom. So an electron is transferred from the outer shell of the sodium atom to the outer shell of the chlorine atom. Since electrons have a negative charge, something that gains electrons would also have a negative charge, and something that loses electrons would have a positive charge. This would mean that chlorine would become negatively charged and sodium positively charged. These charged particles are called ions. A positive ion such as sodium is called a cation, and a negative ion like chlorine is called an anion. So what ionic bonding basically is, it is a strong electrostatic attraction force between positive and negative ions. You can illustrate ionic bonding using dot and cross diagrams. Here's one for the ionic compound sodium chloride. Note that even though the electrons are drawn as dots and crosses, there is no difference between them in reality. Here's another dot and cross diagram for magnesium oxide. Two electrons are transferred from a magnesium atom to an oxygen atom to form Mg2 plus and O2 minus ions. Take a look at the electronic configuration for a few ions. Most of them will have a noble gas structure. For example, sodium ion has an electronic configuration of 2,8, which is the same as neon. A chlorine ion has an electronic configuration of 2,8,8, which is the same as argon. So elements would either gain or lose electrons to achieve a noble gas electronic configuration. So sodium atom has an electronic configuration of 2,8,1. So it has to lose one electron to have a noble gas structure. But chlorine, which has an electronic configuration of 2,8,7, has to gain an electron to have a noble gas structure. However, you will see several other ions that you will encounter in your exams, such as Fe2+, Fe3+, Cu2+, Zn2+, Ag+, and Pb2+, do not have noble gas structures. You obviously can't memorize all the formula for ionic compounds. So to help you with deducing the formula for an ionic compound, here are a few things you need to know. Firstly, an ion is either positive or negative. A compound is neutral. What we can gather from this is, in an ionic compound, there must be the right number of each ion to make sure that the positive charge and the negative charge is equal. Now that we know that, we should see how we can work out the charge of an ion. So an element in group 2 has 2 electrons in its outer shell. So it will lose 2 electrons and form a 2+ ion. With that in mind, take a look at this list. Group 1 element would mean a charge of 1+. Group 2, a charge of 2+. Group 3, 3+. Group 7 elements would have a -1 charge on its ion, since group 7 elements gain an electron. Group 6, 2-, and group 5, 3-. You cannot work out the charges for some ions though. These you will have to remember. Here's a list of some of the most important ions. Okay, here's a question for you. What is the formula of sodium oxide? So sodium is in group 1, which means its ion is Na+. Oxygen is in group 6, which means O2-. So there is 1+ and 2- charges. To balance it out, we need another plus charge, which is another Na+ ion, which leaves us with 2 sodium ions and 1 oxygen. So the formula will be Na2O. Ionic compounds form crystals consisting of lattices. A lattice is a regular array of particles. Here's an image to show the arrangement of sodium chloride. We call this structure giant ionic lattice. The word giant in this case means there is no individual molecules. This means we cannot pick out sodium chloride molecule from a giant ionic lattice of sodium chloride. In a giant ionic structure, the bonding extends in all directions. There is no limit to the number of particles. Most ionic compounds have high melting and boiling point. This is due to the strong electrostatic forces holding the ions together in a giant ionic structure. So more energy is needed to break these strong attraction forces. Ionic compounds tend to be crystals. Sodium chloride, in other words common salt, is always seen as small white crystals. Iron compounds or crystals are brittle, so they tend to break easily because any small distortion will bring same charged ions alongside each other. Like charges will repel, so the crystals break apart. And finally, ionic compounds do not conduct electricity in a solid state. This is because the ions are in a fixed position and cannot move. When they are melted, however, or dissolved in water, they do conduct electricity, since now the ions are mobile. Well, that's all for today. If you preferred it instead of a whack in the face with your textbook, then like and consider subscribing.